Before we can start talking about integrals, we have to be able to find the area under the curve of a graph. So how do we find the area under this curve? We could do what we do in another BOP and just split this into a rectangle and a triangle and find the area that way. But if this was a curved line, that wouldn't work. We couldn't just split it up into shapes. So it would be a curved line. So there has to be some other way of finding the area. There is something we can do to estimate the area using techniques that we already know. To estimate the area under a curve of some function, we're going to have to use a Riemann sum. A Riemann sum is a technique for finding the area under the curve by finding the areas of a bunch of rectangles that are shaped to fit the area under the curve. The equation for a Riemann sum is given by the sum from I equals 1 to n of f of si, and this will be, well, let's say this function is f of x. Then this would be that function times delta x, where delta x is equal to b minus a over n, and s of I is equal to a plus I times delta x, or s of I is equal to a plus I minus 1 delta x. This is going to be dependent on whether we use a left endpoint Riemann sum like we do here. In that case, we would do this. So this is for left, or a right endpoint, in which case we use this one. This equation is a sum where f of s is the value of a certain point on the graph, b is the right endpoint, so b would be here, and a is our start point, or our left endpoint. And n is a number of rectangles, so in this case n would be 1, 2, 3, 4, 5. If you don't already know, this big E looking thing is called sigma, and it just tells you to sum or add something. It's just saying that you add f of si times delta x multiple times. So the first time I is equal to 1, so you do f s of 1 times delta x. The second time, then you add f s of 2 delta x, and you keep going until you get to f of s n delta x. And if we're doing this one, remember n is 5, so our last one would be f s of 5 delta x, and you add all these together and you get the Riemann sum approximation, which you can write as Rn. This summation notation can be a little confusing, so let's do an example. For the graph shown right here, we're going to use b equals 1, a equals 0, and n equals 5, because there's 5 rectangles. And we want to know what the left-hand Riemann sum approximation is, so the one that looks like this. And this is called left-hand because use the left side of each rectangle as touching the line. Notice the top left corner is touching and the top right is not. Same with all of these rectangles. If we used a right-hand Riemann sum, it would be different because the upper right corner would be touching the function and the left wouldn't. So what we're going to do is set up this for n equals 5. Alright, so this is going to be written as the sum of I equals 1 to 5 of f of si delta x. Now, since everything is multiplied by delta x, each of the f s of i's, because there's going to be 5 different ones, 5 different terms here. There's going to be f of s of 1, 2, 3, 4, and 5. They're all multiplied by the same delta x. This changes every time, but this doesn't. So what we're going to do is find this delta of x, and that'll make things a little bit easier because then we can figure out what to use here. So delta x is equal to b minus a over n. Our b is 1, our a is 0, and our n is 5. So what we're going to get is 1/5, or 0.2. So now what delta x tells us is how wide these rectangles are. So we know from here to here is 0.2, from here to here is 0.2, here to here is 0.2, here to here is 0.2, and here to here is 0.2. Which makes sense, because if you have to fit 5 rectangles in a space of, this is our x-axis and our y-axis, if you have to fit 5 rectangles in a space of 1x, well, 1 divided by 5 is 0.2. So we're starting at 0, and that's going to be our first f of si. And since they're all being multiplied by delta x, we can just put 0.2 out here and just worry about this. And if this s thing is confusing, just think of it as a placeholder. It's just saying, hey, you're going to have a different x value for each term in the sum. So the first one is we know a is 0. This is going to be our first f of si. The first x value, which is f s1, is 0. Next we move 0.2. It's going to be right there. That's going to be 0 plus 0.2. So f of 1.0, 0.2, sorry. And then we're just going to keep doing that, add 0.2 each time. So f of 0.4, f 0.6, and f of 0.8. Notice it doesn't go to 1. This is because this is a left-hand Riemann sum. If we had a right-hand Riemann sum, this would look different. We'd end up not having this one because this rectangle would be shaped differently. It would be shaped like this. And so you see the rectangles would be above it. And our last one would be f of 1. We'd have f of 0.2, 0.4, 0.6, 0.8, and f of 1. But we're working on a left-handed Riemann sum here, so that's what we're going to do. Now we just evaluate each of these in here. And if you look below this video on the lesson tab, you'll see these are all marked so you can figure out what these values actually are. I'm not going to go through it and mark it on here because it would get really messy. But just look at that graph down there if you're having trouble following. So this f of 0 is going to be equal to, that's 0.01. It's going to be 0.01 plus 0.012 plus 0.014, 0.016 plus 0.018 times 0.2, and then you just it's just a matter of addition and multiplication, and you end up getting 0.014, and that's how you do a Riemann sum. Okay, now I realize some of you may have gotten lost here, and that's okay, that's normal. This is kind of complicated if you think about it just from equations, but there's another way you can think about it that'll make it a lot easier, and will hopefully make these equations make sense. All this fancy notation is just telling you to add the y values of each place the rectangles touch the line and multiply it by b minus a over n. That's all you're doing. You're just finding, okay, this touches at 0.01, this touches at 0.012, add those together, and then multiply by that, and you've got your answer. You can also find a Riemann sum from equations of functions instead of from graphs. The values for a, b, and n will all be provided for you. Just remember to use the appropriate formula for f of si, because in this one we just plug it in. But if we're given some equation like y equals 2x, and let's say we're starting at 5, well then your first point here, f of s1 would be equal to 5 times 2, and then f of s2, let's say the next point we're doing 5 and then 7 would be 14, so you'd put those in here in place of just plugging in numbers from a graph.